Chapter 26 My Difficult Book Made Simple for Annie and George, Version 3. It began, What you need to know about black holes. Section 1. What is a black hole? 2. Section 2. How is a black hole made? 3. Section 3. How can you see a black hole? 4. Section 4. Falling into a black hole. 4. Section 5. Getting out of a black hole. 6. Section 1. What is a black hole? A black hole is a region where gravity is so strong that any light that tries to escape gets dragged back. Because nothing can travel faster than light, everything else will be dragged back too. So you can fall into a black hole and never get out again. A black hole has always been thought of as the ultimate prison from which there's no escape. Falling into a black hole is like falling over Niagara Falls. There's no way of getting back the same way you came. The edge of a black hole is called the horizon. It is like the edge of a waterfall. If you are above the edge, you can get away if you paddle fast enough, but once you pass the edge, you are doomed. As more things fall into a black hole, it gets bigger and the horizon moves farther out. It is like feeding a pig. The more you feed it, the larger it gets. Section 2. How is a black hole made? To make a black hole, you need to squash a very large amount of matter into a very small space. Then, the pull of gravity will be so strong that the light will be dragged back, unable to escape. One way black holes are formed is when stars that have burned up their fuel explode like giant hydrogen bombs called supernovas. The explosion will drive off the outer layers of the star in a great expanding shell of gas, and it will push the central regions inward. If the star is more than a few times the size of our sun, the black hole will form. Much larger black holes are formed inside clusters and in the center of galaxies. These regions will contain black holes and neutron stars as well as ordinary stars. Collisions between black holes and the other objects will produce a growing black hole that swallows anything that comes too near it. Our own galaxy, the Milky Way, has at its center a black hole several million times the mass of our sun. Section 3. How can you see a black hole? The answer is, you can't, because no light can get out of a black hole. It is like looking for a black cat in a black cellar. But you can detect a black hole by the way its gravity pulls on other things. We see stars that are orbiting something we can't see, but that we know can only be a black hole. We also see disks of gas and dust rotating around a central object that we can't see, but that we know can only be a black hole. Section 4. Falling into a black hole. You can fall into a black hole just as you can fall into the sun. If you fall in feet first, your feet will be nearer to the black hole than your head and will be pulled harder by the gravity of the black hole. So you will be stretched out lengthwise and squashed in sideways. This stretching and squeezing is weaker the bigger the black hole is. If you fall into a black hole made by a star only a few times the size of our sun, you will be torn apart and made into spaghetti before you even reach the black hole. If you fall into a much bigger black hole, you will pass the horizon, the edge of the black hole, and the point of no return without noticing anything particular. However, someone watching you fall in from a distance will never see you cross the horizon because gravity warps time and space near a black hole. To them you will appear to slow down as you approach the horizon and get dimmer and dimmer. You get dimmer because the light you send out takes longer and longer to get away from the black hole. If you cross the horizon at 11, according to your wristwatch, someone looking at you would see the watch slow down and never quite reach 11. Section 5. Getting out of a black hole. People used to think nothing could ever get out of a black hole. After all, that's why they were called black holes. Anything that fell into a black hole was thought to be lost and gone forever. Black holes would last until the end of time. They were eternal prisons from which there was no hope of escape. But then it was discovered that this picture wasn't quite right. Tiny fluctuations in space and time meant that black holes couldn't be the perfect traps they were once thought. Instead, they would slowly leak particles in the form of Hawking radiation. The rate of leakage is slower the bigger the black hole is. The smaller a black hole gets, the quicker it evaporates. Large black holes evaporate slowly. The Hawking radiation would cause black holes to gradually evaporate. The rate of evaporation will be very slow at first, but it will speed up as the black hole gets smaller. Eventually, after billions and billions of years, the black hole will disappear. So black holes aren't eternal prisons after all. But what about their prisoners, the things that made the black hole or that fell in later? They will be recycled into energy and particles. But if you examine what comes out of a black hole very carefully, you can reconstruct what was inside. So the memory of what falls into a black hole is not lost forever, just for a very long time. You can get out of a black hole.